It's Monday. Today we're doing 11-2, day 1. There's actually probably 3 days of material here. That's how we actually split it up in the regular class. But this Friday is the last day I can assign assignments, and that's making this 2 days is the only way to get all your material in before school's kind of officially out. So grades are actually due this Sunday night at midnight, so any assignments you have done need to be done by then. But we're just going to do as many problems as we can. We'll just get through it. Worst case scenario, you can look at the answer key. And then tomorrow I'll be able to come back and answer a couple more questions about this as I teach tomorrow's lesson. But okay, today we're doing rational exponents. We're talking about changing from radical notation to rational exponents. Okay, so I'm just going to do several of these and rewatch it if you need to. I'll post some extra videos in the extra resources page if you just need to see more details. Okay, so writing in radical notation. What you're going to do is the denominator is going to be your index. This is going to be a fourth root. The numerator is going to be the power of your number on the inside. And this is your number on the inside. And there's actually two ways to write it. You can either write 2 with a 1 on the inside, or you can write, well, that's a 4, 2 with a 1 on the outside. As long as that 1 is an exponent to the 2, whether it's inside or outside, these are equivalent to each other. Okay? So index is 2, so it's automatically going to be a square root. I could either put x cubed, or I could do square root of x, and then cube that thing there. Doesn't matter how you do it, and they actually each have their own benefit, and hopefully you'll see, and I'll try my best to explain it as I go. Okay, here the base is 6x, so the index is 3, so it's going to be a cube root. The entire base is 6x. Okay, and then you can either square that on the inside, or you can do cube root 6x, which I guess you wouldn't need a parentheses in this case, squared. However, you cannot just write 6x squared because then you're only squaring the x. You need to be squaring both the 6 and the x, whether it's on the inside or on the outside. Okay, now this one, the exponent is only touching this, so this is actually an outside number. So you're either going to write 3 with a fifth root of x to the fourth, or fifth root of x to the fourth, and then that 3 is on the outside. So we're very careful about what's actually touching things. If the exponent's touching everybody, then you better make sure everybody gets it by using parentheses. If the exponent's not touching everybody, meaning it's only touching the person it's touching, make sure that other guy is on the outside and he's not being raised to any power. All right, conversely, just going backwards, is if you have a base, my base is 5, my denominator is the index, so it's going to be a 7th power, and then my exponent, or the numerator in this case, is whatever number is either on the inside or on the outside. In this case, there's no number, it's understood 1. Okay? This one, my base is just the big thing, so it's going to be x. My denominator is going to be a 4. My numerator is going to be a 3. X to 3/4. Okay, this one, my entire base is 2x, so I need to use parentheses. My index is understood 2. My exponent is a 5. 2x to the 5 halves. You have to have that 2x in parentheses. Okay, this one, you could write it a couple different ways. You could treat them separately. Let me show you how to do it together, though. You could do this. The entire base is 5x squared, and then the denominator is a 3. And how many 5x squareds? Oh, I forgot my squared. How many 5x squareds do I have? Well, I only have one of those. So you could treat this as the entire base, like it's a parentheses, and then say I only have one of those. So 5x squared to the 1/3. Or you could treat them separately. So 5 is my base. How many 5s do I have? Only 1 to the 1/3. X, base is x. How many do I have? I have 2. Index is 3. So if you do want to write them separately, just push them apart. Or if you're going to use the parentheses, then you would need to make sure that you take that 2 on the inside there. All right, so that's really all we're learning. Now we're just going to use it. And this is a tough lesson. People have trouble on this one. Okay, so what you're going to do is you're going to decide, can I solve this problem as is, or do I need to change some form? So do you know what the 10 through to 25 is? I sure don't. So this is not helpful in the current form it is, so I'm just going to go ahead and change its form. Well, the denominator is 10, the numerator is 5. Okay, oh, well, 25 to the 5/10 is 1/2. Okay, well, I still don't know what that is. Oh, but I could do this. 25 is my base. Half means index is 2, and there's only one of them. So that's actually a square root. What's the square root of 25? That's 5. So that would be unsolvable without a calculator because you wouldn't know what to do until you change it into a radical, or change it to radical notation and then change it back. So that going back and forward. Okay, I'm going to show you 3 ways to do this, and then we're just going to go through as many problems as we can. All right, so a couple of different ways. Method 1 is to just change this guy. So he's going to be a square root, and then he's going to be 16, and you can put the exponent on the outside or the inside. Does not matter at all. Most of the time, I prefer to put the exponent on the outside for numbers and on the inside for variables, and you'll see why. All right, because 16 is a perfect square, this actually ends up being just a 4 on the inside, and then cubed, and 4 cubed is 64. So that was a very easy way to just solve that one. Okay, the other way is to do the exact same thing, except put the exponent on the inside. They're both exactly the same thing, but obviously solved differently. This means I have 16 times 16 times 16. I'm not going to multiply that out because I know 16 is a bunch of 4s. So when I pull all those groups of 4 out, I end up with 4 cubed, which again is 64. So same exact answer, obviously. Okay, and then the last one is to treat it as it's an exponent. So you could do 16 to the 3/2, and this is a trick I'm going to show you here in just a minute. 3/2 is the same thing as saying 2/2 plus 1/2. So you could break this up and say 16 to the 2/2 plus, not plus, I'm sorry, when you're adding exponents or multiplying, times 16 to the 1/2. Well, 16 to the 2/2, same thing as saying 16 to the first power. And then what is 16 to the 1/2? Well, that's the same thing as saying the square root of 16. Because remember, index 2, exponent 1. This ends up being 16 times 4, which ends up being 64. So really pick whatever you're comfortable with. If one method doesn't work, just try something else. And then hopefully when we do the ones in the back, you'll see. All right, we're just going to do as many as we can. Okay, 27 1/3, not a clue what that means currently, so I'm just going to go ahead and change its form. It's going to be a cube root of 27, doesn't matter where the 1 goes. Oh, cube root of 27 is 3 times 3 times 3, which is 3. Cool, that was nice. All right, -8 and then to the 4/3 power. You could do it a couple different ways. My base is -8, cube root, and then decide, do you want the 4 on the inside or the outside? Well, I know that -8 actually is a perfect cube. It's -2 times -2 times -2. So if you put that 4 on the inside, you're just going to make yourself multiply bigger and bigger and bigger numbers. So most of the time, put the number on the outside of the exponent. That way you can take care of this entire inside, get a -2 to the 4th power, and then -2 to the 4th power is just 16. So it's much easier, for the most part, to put that exponent on the outside. Okay? This one is a negative exponent, though. So I'm going to do square root, base is 4. I don't want to put a negative on the inside for sure. I'm going to put that on the outside. Okay? Well, also because, what is the square root of 4? Well, that is 2. So now I have 2 to the -3. Well, don't forget, negative exponents mean move that guy downstairs. So that's an equal sign there. So this is going to be 1 over 2 cubed, which 2 cubed is 8. Okay? All right, that's kind of all of those. Now we're going to kind of just change gears a little bit, which is why it could have been 3 days. We could have made these their own day, but you guys just don't have time for that. Okay, so all of these, we were just changing form. There was just one, expression thing here. Well, here, now we're going to do ones that are multiplying or dividing. But we've already learned how to do this before. We know that when we multiply, we add exponents. So this is going to be 12, and then a -1/2 plus 5/2 is going to be 4/2. Now I have one base and an exponent, and then just use logic. Whether you need to change it into the square root or just deal with the exponent as is, it makes it easy. 4/2 is 2, 12 squared is 144. As long as the base is exactly the same. Okay, so down here, base is -4, and both of these, oh, this is actually supposed to be a 4/3 here. That's a typo on my part. Okay, so -4, same base, so I'm going to have a -4. But don't forget, when we divide, we actually subtract exponents. So 4/3 minus 1/3 is 3/3, which is the same thing as saying negative 4 to the first power, which we know is just straight up negative 4. So when they're touching, multiplying, or dividing, you're going to either add exponents or subtract exponents. Okay, this one right here has a whole bunch going on. I have a multiplication and a division. Take care of the top first. So my base is 6. I have 4/3 and then understood 3/3 because I want to have the same denominator. So 4/3 and 3/3 is 7/3 divided by 6 and 1/3 to the 1/3. Okay, add it on top, but now that I'm dividing, I can go ahead and subtract. So it's going to be 6 to the 7 minus 1 is 6/3. 6/3 ends up being a 2. 6 squared is 36. But again, if one of these numbers ended up being like not perfectly reducible, you could just change it to that radical form. The cube root of 6 to the 6th power or something like that. Okay, kind of changing gears again, same sort of setup here. These are not multiplying. These are adding and subtracting, which means they don't do anything to each other at all. You straight up treat this guy alone and then treat that guy alone. So 8 to the 2/3. Not sure what that means. So I'm going to go ahead and change that to cube root of 8. And then either the 2 can go on the inside or the outside. Well, I know cube root of 8 is perfect, so I'm going to make sure I put that 2 on the outside. Cube root of 8 is a 2. So it's 2 squared. Same thing over here. I'm going to say cube root of 8, and I don't want to put that negative 2 on the inside, so I'm going to put it on the outside. So that ends up being 2 to the negative 2. Well, 2 squared is 4. 2 to the negative 2, don't forget that's 1 over 2 squared, which is 1/4. 4 plus 1/4 is, I'm just going to write it as a mixed number, 4.25 or whatever. All right, same thing here. These guys are not touching, and they're definitely not the same base either, so there's probably no tricks here. You just separate them and do the math separately. Don't know what that means, but I do know it's a square root, 25, first power, who cares where it goes. 4th root, 16, first power, who cares where it goes. Square root of 25 is 5. 4th root means 2 times 2 times 2 times 2. This guy's a 2. The whole thing is a 2 there. So then 5 minus 2 is 3. Okay, moving on down. I want to make sure I get to these last two. Moving on down. Okay, so this one, a couple different ways you could do it, but I'm just going to try to find the clearest path I can. So currently, I can't do anything as is. I don't know. I mean, I guess I could raise these powers to powers, and you could do that if you want to, but I'm just going to go ahead and change the form. So I'm going to put inside 16x to the 4th, and this is going to be a 4th root, and it's going to be cubed. So I'm going to put that on the outside. I definitely don't want to cube 16. All right, well, we just said that the 4th root of 16 was 2 over here. So the 4th root of 16 is 2. And the 4th root of x to the 4th, 4 goes into 4 one whole time with no remainder. So this guy actually is a perfect radical, so he is just straight up 2x. And then don't forget he's raised to the 3rd power. But they don't always work out like that, so I'm going to show you this next one in just a second. Okay, but then here, cubing, you're going to kind of, remember, you kind of distribute. 2 cubed is 8. X cubed is x cubed. So that is your final answer on that guy. Okay, minute and a half to this guy. We can do it. Okay, so here, a couple different ways to do it. I knew this guy would work out perfectly. Once I saw it here, I'm like, oh, it's going to be perfect. But this one's not going to work out perfect because the denominator doesn't match. So 4 and 4, but 2 and 3 don't match. So that 4 over 4 ends up being 4 divided by 4, which is what I was trying to talk about. And that 2 over 3 ends up staying 2/3, so it doesn't work out. Okay, so I'm actually going to pull that number in that variable part. So I'm going to say base of negative 27, and I'm going to say cube root, and I'm going to square that. And then I'm going to say over here, it actually makes more sense just to raise powers to powers, because that's how we deal with variables. So I'm going to say times, and this ends up being 2 over 1. So 2 times 2 is 4. And then 1 times 3 is 3, so 4/3. Okay, dealing with this guy over here, and I guess I should put parentheses. Cube root of negative 27, that's negative 3 times negative 3 times negative 3, so he ends up being negative 3 squared, so he ends up being a 9 overall. This one, again, you don't know what it looks like, that is the same thing as saying the cube root of x to the 4th. Well, how many times does 3 go into 4? Well, it goes in there one whole time with 1 remainder. So you are able to break those apart. So if they are multiplying a number and a variable, you can treat them separately, especially if they don't work out perfectly. But for the most part, you're doing delta math, so they should, I think, mostly work out perfectly. Okay, we made it! See you guys.